Okay. So this is yesterday's questions, right? So I think I will try to discuss this one question and one question from chapter 3. So I think this week I will finish the grading. So far, I have seen 2 or 3 students I have giving the score. I think if we have, and I think we will have a makeup exam for yesterday exam. So, but the makeup exam will be 1 hour only. Okay, so maybe only 2 questions for that makeup exam. 1 hour, 2 questions, and that 1 hour will be next week. So today is 16, so 23rd of April there will be the makeup exam. But after makeup exam we will have 2 weeks, and then we will have a quiz. Okay, so next week probably we have makeup exam, only 1 hour, Tuesday. So this is, let me explain this a little bit and I will get back to the exams and quizzes later. So this figure, it says that it has some safety factor. So what is safety factor? So safety factor is the ratio from the failure and allowable loads. Okay? So from this diagram, the first thing we can try is basically making the all the forces diagram. So taking this AC, the boom AC, right? And taking this P, and then since L is 1.8 meter and AB is L over 2, I will write, this will be 0.9. And then at C we have pin supports. And then at B we have another member force. Let's name it FPD. Okay. I think we have all. And then since we have the distance L over 2 is 0.9, let me write here, and H is 1.2, what we do have here is basically 3, 4, 5 triangle, right? So we have, if we divide by 0.3, we have 3, 4, and 5. So we can use this triangle to assemble the component for FPD, make it in sine and cosine, right? So you could have, here is the sine component, this is this cosine component, right? Okay, just to name all this possible list of forces. Okay, and in the informations, the bar BD, you have, first is the thickness 25 millimeter, and then you have the sigma yield 250, and the shear, which is 410 megapascal. This yield and shear ultimate, this will be used for the safety factor. Okay, so we have safety factor here and here, right? Okay, now as standards in our courses, after we draw all the forces possible forces and all the components, the next step is we are going to take the equilibrium. So first start with diagrams. So this is diagrams. And second is the equilibrium right here. You can write first sigma F, sigma M, but usually if there are more than one unknown forces, we could start with the sigma M. So we only know the P, right, which is 11 kilonewton. So we can have the sigma moment, and you could take at B or at C, but I would like to know the BD because BD becomes important, because we would like to know the thickness for the rectangular BD, the required thickness that we can get from the safety factor and also from the forces at BD, right? So that's why I will take this with respect to C and then take it that moment as a positive moment, take it equal to 0. So this will be minus P 1.8 meter, right? And then plus the FBD sine theta. Theta will be this part here. So sine will be 4/5, right? So we can write 4/5. And then this will be 0.9 meter. Okay, and it's equal to 0, and we get the FBD, right? We can get FBD. So FBD is P we can cancel this 2. So 5/2P, which is 2.5 multiplied with 11. So it's supposed to be 20 something. Let me just write the final results. As we know, this will be 27.5 kilonewton. Okay. Now, because the required question is only for BD, so we can focus now, shift to FBD. Okay. So we can use the factor of safety or safety factor sigma is 3.5. This Fs will be sigma yield over the loads. Okay, let me write loads. Loads mean the stress. The stress that is going to be applied, and the stress that going to be applied will be the FBD over the area. Okay, so this from this FBD we get right allowable loads, or perhaps let me just write this the loads that is going to be based on this 27.5 will be 27.5 kilonewton divided by is from F over A. So area is B is 25 millimeter, and we have the thickness. So B is the height and T is the thickness. So B multiplied T is our area. Okay, do you see it? Where is the thickness? Where is the thickness? Thickness is this. This B is the height. You see it? So thickness means that over there. That's the one that we want to find. So the area, the cross section is B, this part here. We call it this. Okay. So here, let me write the area will be B multiplied with T. So here we can write is FBD divided with B and T. Now we can put everything. So and then we can get that. Okay. So basically that's how we see. So always remember that the safety factor is always the ratio between the sigma yields and the loads. Loads means the allowable loads that can be tolerated. Okay, so we get everything here, we get the T, put everything that we have from our information and done. So safety factor is 3.5. This multiplied with 27.5 kilonewton. Sigma yield is 250 MPa. Remember, MPa means Newton over millimeter squared. And B is 25 millimeter. So I can write the kilo to make it maybe similar notations with that. Okay. Safety factor is dimensionless unit, so we can get everything, right? So as expected, we get the millimeter. So T will be, if we compute, I would just write down the numbers. Maybe it's not correct exactly the decimals, but this is rounded for some around decimals. Let me just write this. Okay. Okay. Now the second question from this part. Okay. So I think the first part should be linear, straightforward, and get your thickness from the safety factor. Now the questions on the second part is the required diameter of the pin at C. So the pin at C, remember that we have a forces that is going to be assuming we have these two forces, right? We have the Cy and Cx, which they both have the resultants of C. Okay. So if we take this, they both have, let's say, this magnitude C as their resultant, if we know the Cx and Cy, right? And that's, I think, the one that we need to follow. So again, we can go back to the equilibrium. So this is the first part. Now, how to deal with this question is actually you can write the equilibrium first, all the things you need at the moment, and then the sigma f if you need, because sigma f is expected, because you need to know the other part of the forces. For example, this is something that we don't know yet, that we can know from equilibrium on forces. Right? So we can write that in your equilibrium. So let me just write on the right side. Let me just write both like this. And then from the figure, we get that the vertical, we can get if we take the moment at B, actually, if we take the moment at B, we can get immediately Cy, right, and B, right? We can also do that. We can take, for example, C1 with this FBD with P, we get the same result. Any way you can take, both will be the same result. Okay? So you can take, let me just write, you can take sigma moment with the B as our point of view. Okay, this is all get true, and you get, for example, if we take the sigma of x equal or y equals 0, this will be FBD sine, or now is 4/5 plus Cy equal 11 kilonewton. So Cy is, what is this? 4/5. Let me check, just to make sure my calculation is correct. Yeah. So this is 22. So Cy is negative 11 kilonewton. So if you see the moment, with respect to B, this equal this, the same distance, the same force, right? Get it? Distance 0.9, 11. Cy should be 11, right? If we take moment here, equal moment here, right? Okay? Logically makes sense, right? And then usually after you see some explanations on exam, you will feel some regrets during exam. But hopefully you can get some overview. So this will be FBD cosine, or 3/5 plus Cx, right, equals 0. So Cx is 16.5 kilonewton. So actually they are going to the opposite direction, but that's okay. What we need is only the value, okay? Because we want to know the resultant at C. So resultant at C, meaning the force that will make through to the pin C. This can be understood as the magnitude from the Cy squared plus Cx. So we can take all this number, and since it's squared, it doesn't matter which direction it should go. And after some calculation, you get that C will be 19.83 kilonewton. Okay, now what we need is this C will be our forces for the shear. Okay, so this will be shear force. Okay. This is, we can say that this is actually our shear forces. So in terms of which one is normal, which one is shear force, it depends on the situations. In this situation here, since this is going to be the forces at pin C, we are going to take that forces, and imagine that the forces will be applied here, which is actually, if you see this view, you need to know that this will be about a shearing forces. Okay? This is what we call the direct shear. And see, 1, 2, 3, it will be double shear. Right? Double shear means when you divide the force with the area, you need to multiply by 2. Or twice as the single shear, right? So now we can write down, let me write here, The safety factor will be works very similar to the between sigma and the shear. So for the shear is 3.3. This means the same as what we have here. This is sigma y, but I will write here, this is the tau or the shear stress divided by, let me just write loads. This is supposed to be the allowable load, but I will just write loads. Now loads means this Vc divided by area. Now loads is Vc divided by, this is 2A. Since we are using the diameter, so I will write diameter squared over 4. So this will be and then we can multiply, this is F as tau pi d squared over 2 equal the Vc tau and Vc, right? And then d squared will be oh wait. Wrong. I make it wrong multiplications. So this will be, let me write here first to make it, to avoid mistake. So Vc over so that will be Vc over pi over 2 d squared so tau Vc right, and divided by tau. Okay, so pi d squared, this is 2f as tau Vc. Let me just write pi down there, and then d will be square root of this. So 2 multiply with 3.3 and 19, sorry, 19.83 kilonewton. This is Newton pi, and then the tau is 410 Newton over millimeter squared. Okay. Okay, we expect to be having millimeter squared, and then take the square root, becomes millimeter. So d for this one will be 10.08 something millimeter. Okay, and that's how we get the questions. Okay, this is the last question, Israel, right? So again, we expect to have a makeup exam, I think. So the makeup exam will be taking 1 hour only. So I was maybe preparing 2 questions at most, not yeah, only 2 questions, and expected to be next week. Okay, so by this week I will try to finish. I have just making a quick review on your score. I think only half of the total students. I mean, just like a really quick review. And I think we need the makeup exam. Okay, that's the questions. Okay. Okay, that's a little bit on yesterday's exam. I would like to take on, wait a moment, this part here, which is, I have been giving you this in exercise actually, the same thing, and I expected you to work on this, but I think no one working correctly. I'm not see clearly every details, but what I have seen is I think no one work on this part very clear. Actually, for this one, you can get easily number B. So if you have B 80 kilometers, and you have this area for each part, and then you can plus, and then this divided by the area, you get the result. Finish for B. But the A is need more observations. You need to see it could be rectangle this and that, or so you can have, let me get to you. You can have rectangle as this, and the second one is from here, right? Because everything has their distance, so you can choose this and this, or you can make something like this. Okay, both are okay. Nothing really matters, because what we want to find is the centroid for both of, if we combine both of them, right? So let's say we are going to have this. So the total is this one is 100, the height, but this distance give you 12.5 millimeter, which means this part, this is going to be 87.5. Okay, and then for each one of them, let's say this is number 1, number 2, they have their own centroids. So if we put this one is here and this one is here, we can make it in like, name it like C1 and CZ. And what else do we have? So we have 75 at the bottom part. So again here, Okay, let's say that it's 75. But we have here is 11.4, right? Which means the rest will be 75 minus 11.4. So this type of question, you need to make every distance geometrically be observed. Okay. So this will be 63.6 millimeter. Okay, and then since this is our base rectangle, which serves, if we take a point here, this is clearly in the middle. The centroid is in the middle, right? Which means we know this distance will be half of this, right? Okay, so now we need, first is this. We have this is 50, right? And this one is from here to there. Okay, that will be 63.6 divided by 2 plus 11.4. This will be 43.2 millimeter. Okay, so I'm trying to describe all the possible length, and then we can write the A1 for the area. It will be 11.4 multiplied with 100. And area 2 will be 12.5 multiplied with 63.6, which gives you 795 millimeters squared. Okay. So the centroid, if this centroid 1, this is centroid 2, our centroid is supposed to be here for the whole argument here. So then we are going to add this two and to relocate, which is exactly our centroid for the whole masses. Okay. So we can write the total area . Okay, first we are going to take the YR, which means this axis, we want to know which one. And the second part, we would like to know the z-axis. So let's say we want to know the y-axis first. YR is equal. Now we focus on both of the area that is affected by only the y-axis. Okay. Okay. This will be A1. Okay. Multiply with the height . Let me write T1 first, just to give you the notes. T1 over 2, which is at the half, okay, which means it's supposed to be the 50. And then plus A2 multiply with T1 plus L2 over 2. L means the length, the width. Okay, this T1 plus L2 over 2 means that is the one that is going to be, sorry, this T1 is actually, so L is for the, so every part you see here, every time you see the rectangle, I forget to write here, this will be T, this will be L. So if we have this will be T, this will be L. Okay, the longest part will be the L. This is the, okay, yeah, and the ZR so YR is all the horizontal line, which means A1 multiply with the T1 over 2, this one, and then A2, this is T1, the whole thing, multiply with the L2 over 2, this one. So this is 43.2. Okay. Now, expected for ZR will be all the vertical lines, okay, all the vertical lines. So ZR, if you look at the A1, we are going to have A1 and then L1 over 2 between this. Okay, so we can add A1, L1 over 2 plus A2. Now for the second part, we only have the area 2, which is only this. Remember, for the first part, since the area is for the second shape needed this distance, we need to add this one. But since this from the ground, we need to go up. Okay. So we only need to multiply this with the T2 over 2. Okay. Now we can compute all of this. So A1, T1 over 2, 11 over 4 over 2 plus A2 is 795, T1 plus L2 over 2 will be 43.2. Okay, divide by 1140 plus 795. You can also check it using your calculator whether the numbers are similar or not. This is supposed to be 21.11 millimeter, and then ZR is L1, this is 50 plus 795 and 12.5 divided by 2 divide this is supposed to be 42.52 millimeter. And if we look at where does it going to be resides, so since this is 75, okay, the base is 75, we get the Y is 21, so perhaps it's around here, and then Z is 42, so perhaps it's around here, which is, I think it's giving you makes sense, logical sense that the centroid will be here. Okay. So YR and ZR is actually our axis at this point and this point. Not sure you get this correct or not, but this actually questions related to the centroid of mass, which is supposed to be in physics. The whole thing here is just playing with the geometry. So So basically, we want to find the centroid that is going to be the combination will be around here. We need to find y, which one, and then z. Y and z. Okay. So for the z, I think it will be okay. For this one is only the ground is start from 0 to here. This is also the same. Nothing to worry on z. But for y, for the first geometric shape, it's only this. But for the second part, we need to add this with this, right? Okay. So I think that's sum up the questions. And I believe number B is okay. So stress will be 80 kilonewton divided by the whole of that. This will be around 41.34 MPa. Okay.